Hello guys, welcome back to my channel. Today we're going to be starting a series on logic gates and truth table, okay? And this question is coming from the 2025 May June Cambridge Computer Science paper 2, and we're dealing with component 2.1. Okay, so here is a problem, and we are required to draw a logic circuit for this logic expression. So this is a logic expression, and our job is to draw logic circuit for it. And this one says each logic gate must have maximum of 2 inputs. Okay, yeah, of course, because you have the AND gate here, so just 2 inputs only. 2 inputs only. Okay, and then the NOT gates with 1 input only. Do not simplify the logic expression, so do not change this expression for any reason. So just represent it the way it is. So I am going to be using this online logic emulator or a simulator to quickly draw this so that you can see how it's done. If you want to use this, please do well to go to logic.ly right there, and then you can try the online version. It's completely free. Then you can close this. Okay, so here you are. So if you check, you would see the input controls. So you can use any of the inputs if you want. You can use any of the outputs. So you have the light bulbs there, okay, and then the 4-bit digit. You can use the logic gates. You can see they're all there. And so, but for our work, we'll basically be using a few of this. Okay, we're not going to use everything here. Okay, so here we are. We're viewing this side by side so that we can quickly draw it. Okay, so for your A, B, C, I'm going to use this toggle switch here to represent our A, B, and C. Okay, so you're free to think we're going to use 3 of that. So, but for you drawing on paper, you don't need to do all of this. Okay, you just draw your lines to represent them. You don't need all of this, but I'm just going to do it for ease of representation. Okay, since I want to do it online so that you can see it. I'm just going to get a text here. I'm just trying to recreate what we have there. Okay, I just want to recreate what we have here. So I'm going to change this to A, change this to B, and then this to C. So remember, in the exam you don't need to do all of this. Okay, you're drawing it on paper. Yeah. Okay, so the next thing is that we now need to represent this very expression. So how do we do that? We start from the inside. Okay, we start from the inside. Whatever we have in the bracket, remember the idea of the BODMAS, the bracket first. Yeah, good. So we are going to start from the inside to represent what we have on the inside and then finish on the inside with this before we can now join the output of both of them to the exclusive OR gate. Okay, so if you check here is A and B, so I'm just going to get the AND gate. Okay, that's the AND gate, so I'll drop it there. So what do we need to do just to join them together? That's A and B, right? Good. So that's A and B. That's the AND gate. Beautiful. The next thing we need to do is to equally do the same thing for this bracket here. So NOT C should come first. Okay. So we go look for a NOT gate, there, and then we can join them together. Yeah. And then after that, we now need to get the OR gate. Where is the OR gate? OR gate is just there. And then we can drop the OR gate here. Okay, so after that you are now to join the result of the NOT C. Yeah, so you're taking the NOT gate and you're joining to this, and then you're taking the B input, and then you're joining it to that. So that becomes what we have. So we can move this a little this way so that they look okay. So this is beautiful. Okay, so the next thing we need to do is to now get our exclusive OR gate, okay, and join these two outputs to it. So that's basically it. So where are we? This is the OR, I mean the exclusive OR gate. So let me take these guys out. Where are you? Not there. So let me do that again. Okay. So let me take this logic gate out, and there we are. So we can now join the two outputs. Okay, we join this and then we join that. So ah, good. So here we are. So this is our x. Okay, so let me go back here and get the text. So this becomes our s. Yeah, we're done with the logic circuit. Our next task will be to complete the truth table for the given logic expression. The same trick applies here. You start from the inside, finish what you have on the inside, and then you get the output. Okay, you also do the same thing with this, and then use the output to feed into the exclusive OR gate. So to make this a lot easier for us, I'm going to just draw. So remember that this very area is left for your working space. I've seen a number of students who are quite clever. They just do it straight without using the workspace. I don't think there's a problem with that. Yeah, but just for you to be careful, you can use your workspace. Okay, so that way you're sure that you're not making any mistakes whatsoever. Okay, so this is what I would do. So here I'm going to do the A and the B part and do not C. So that way I've simplified this. So whatever is the result that I'm going to get from this, I know I'm now dealing with this and that. Okay, so I'm just going to draw a line to separate them. Yeah, the whole of this is now the x. Yeah. So, but remember, you don't have to do this last part in your exams. It's not necessary at all. Okay, and this working is just there to help you so you avoid mistakes. Okay, so let's do that together. So now we have A and B. So A and B, of course, you remember logic gate. If you were taught, 0 and 0 should be 0, 0 and 0 should be 0, 0 and 1 again 0. Okay, 0 and 1 0, and then you have 1 and 0 0, you have 1 and 0 again 0, 1 and 1 should be 1, and 1 and 1 should be 1. So you should basically understand this. Okay, so let's move on to the not C. Not C is just the inverse of C. So whatever we have here, we inverse it. Okay, so this is a 0 1, so 0 will be 1, 1 will become 0, 0 will become 1, 1 will become 0, 0 becomes 1, 1 becomes 0, 1 becomes, 0 becomes 1. So you need to be careful with this, okay? 1 becomes 0. So let me double check, please. When you do this, double check, double check, double check. 0 0 0 and 0, 1 0, 0 1, 1 0, 1 0 0, 1 1. Okay, so the A and B is okay. So let's double check the not C as well. 1 0, 1 0, 1 0, 1 0. So looks like we're good on this part. We're now dealing with this not C and B. Yeah, good. At this point, we're using the OR gates. Yeah, so 0 or 1 is 1. 0 or 0 is 0. 0. Okay, here now we have 1, 1, 1. You need to be careful. Here you have 1, 0, 1. Here you have 0. You see, I almost made a mistake there. 0 1 1, 0 0 0, 1 1 1, 1 0 1. Yeah, so you need to do this carefully. It's not difficult, but you can easily make mistakes here. So let's now handle the proper output that we are looking for. Let me change the color of this. We're now dealing with this as an input, and what's the other one again? this. Okay, so we're not dealing with these two guys. Okay, to give us the result of x. Okay, so let's do this again carefully as we can. Okay, so we're dealing with that and that. So this one is the exclusive OR gate. The exclusive OR gate, like 0, 1 will give you 1. Since we're dealing with two inputs only. Okay, so 0, 1, 1. 0, 0 will give you 0 since the inputs are the same. Okay, 0, 1 will give you 1. 0, 1 will give you 1. 0, 1 will give you 1. 0, 0, they are the same, so we'll take 0. 1, 1 will give you 0, they are the same. 1, 1 will give you 0, they are the same. So I believe we've done justice to this question. So I believe you learned something from this video. Please do well to like, do well to share, do well to subscribe, okay? By doing so, this video gets to as many persons as possible. Thank you for taking our time to watch. If there is any question that you want us to particularly handle, any computer science, whether it's AS, A level, IGCSE, do well to let us know. We'll try to treat them as much as we can. Thank you guys. I'll catch you again in the next video. Bye for now.